Hey everyone, very good evening. Welcome to PyNet Labs, and my name is Jatin, and I'm working as a senior Cisco instructor with PyNet Labs. So, as a scheduled webinar today, we are going to discuss a lot of things related to the policy-based routing in this webinar, and it's gonna be very much interesting because to understand the policy-based routing, we have to understand the routing part. So, basically, as the prerequisite was already mentioned, that you must be having some good routing knowledge. So accordingly, we are going to understand how basically the policy-based routing is going to work and what are the different advantages which we get with policy-based routing? What are the types of policy-based routing which can be implemented? And apart from this, do you know that in case of the policy-based routing, this policy-based routing was initially a topic of CCNP and RC, but as the certifications has recently revised now. So with the latest official certification of CCNP ENCOR, which is the version 1.1, that is also going to include the policy-based routing, but that is going to have some limitations. Like we don't have specific details to discuss over there, like what exactly the route maps are and all these things. But yes, for sure, in this webinar, we are going to cover up each and everything. Initially from the start to the end, how basically the policy-based routing is going to work and how we can define the policy-based routing over the devices, and what are the various advantages we are going to get it via the policy-based routing. So let's get started. Let's don't waste much time. So guys, you know that as the name itself represents policy-based routing. So basically, policy-based routing in simple, if I'll say policy-based routing, that is what the webinar we are going to talk about. So in the policy-based routing, It is a type of routing that is somewhat defined by the network administrator, right? It is not a normal routing. So it is something we can say defined by the network administrator. Because like normally, suppose that if you are having a scenario like you have to implement routing over multiple devices. So in that case, you are going to define the routing, and on the basis of the default behaviors, the packet will be routed towards the destination. But PBR is a kind of feature which is enabled on the network devices, where it's going to give you flexible routing, which is basically, we can say, defined by network administrator, as well as it is based on policies. So all the policies we have to define, like what kind of specification we want to make sure that this should be there inside the network. The data should travel via this path. This data should not go via this path. So many things like that we have to define here. And guys, the PBR allows you to override the traditional routing table as well, which means to say that we can say whenever we are defining the policy based routing, it will just simply override the traditional routing table decisions, which is based on the attributes, or you can say on the based of packets as well. So I'll mention the same point. So we can say that PBR allows you to override the traditional routing table. Allows you to override the routing table, or you can say the traditional routing table, which is traditional in the sense I'm talking about the IGPs or the normal routing behavior, how basically the packet is being destined from source to destination. So that is what, like, it's going to override the traditional routing table inside the devices. And on the basis of various attributes, or on the basis of various parameters, we can configure the policy based routing, where we can say that the major advantage is that it's going to give you a fine grained control over the flow of the traffic in the network. Because with PBR, you can direct, you can direct packets through the different or various paths, or you can, you can say that some of your traffic should not go via this, or some of your traffic should not go via this particular path, or any other, you can say whatever the policy you are going to define. So let's try to see an example. So as of now, I'll just give you a theoretical example to understand how basically this policy-based routing is going to work, and what are the advantages of doing this policy-based routing. Suppose that I'm having some router. Let's say this is my R1. This side I'm having is router 2, and this side I'm having is router 3. And the same implementation I'll be doing in my real-time lab as well to show you. So let's try to understand this with an example. Let's suppose that there is some connectivity which is established between all these devices using some serial links, but in the real, we are not going to use the serial links because they are not really used. Now, suppose that this side on the link, I'm going to have some, let's say 1.0 network. This side, I'm going to have some 2.0 network. Slash values will be the default 8. This side, you can assume .1, similarly .2, again .1 and .2. Again, here also, let's assume that there should be some another network, let's say 20.0.0, .1 and .2. Now, suppose that over the router number 3, basically, that over here router 1 and router 2, why I have additionally created two links here? Because I'll be saying there will be a concept of primary, and there will be a concept of secondary as well. So these should be there, and according to that, we are going to see. So now by default, as the normal routing packet, whenever the normal routing packet is going to enter inside the LAN, so it's going to reach the router number 1, and the routing table will be checked. Based on the routing table, it's going to check the destination. If any destination is available to reach on the specific destination, then in the routing table, it will look for the destination, and routing table will take the decision to forward the packet. Now, my requirement is that suppose this link number 2.network, or this particular link, which is having some network of 2.0. So this link should be my, we can say, primary link, or the second link will be installed in the routing table. Like for example, as of now, right now, assuming that these are the both the links are there, link 1 and 2. So the first link, let's say the primary link is having the network of 1.0.0. Secondary link is having the network of 2.0.0. Now, when I say the normal routing behavior, so in the normal routing behavior, let's suppose that according to that, the primary link will be given the preference, and depending upon the routing policies as well, that which routing protocol you are going to implement. But what I can do with specific policy-based routing or using some route map statements, I can make sure that any traffic, suppose that there are some networks on the router number 3, assuming that there is a network, let's say 12.0.0.1. There is another network 12.0.1.1. Both of them are having /24. And I want to make sure that the traffic of 12.0.0.1 should go via the link number 1, and the traffic of 12.0.1.1 should go via the secondary link. So in that case, you have to match some specific traffics. So basically, while mapping, either I can define the next hop, I can define the next exit interface. So we have to write all these statements. So accordingly, we will see the same thing in the lab section as well, that how basically these statements can be defined over the devices, and how come we are going to say that it will be considered as policy based routing, because we will be putting up some policies here accordingly, like which traffic will be from which link and how we can destine the specific traffic as well. So now once we are going to write the statement for the policy based routing is checked before the routing table, which will define some conditions and some specific network, where I'm going to say that if my network is going to match, in that case, the traffic will be allowed to, go via this link which I'm going to define in my policy. Else the traffic will be going via the normal routing behavior, whatever the routing protocol should be there. So basically, by doing this policy-based routing, what are the exact advantages we are going to get here? So the major advantages of doing PBR is, so let's write about the advantages. So when I say the policy-based routing and the advantages, so with the advantages, the first advantage is that we are going to get a better traffic management. And to define the term traffic management, I can say that it's going to allow you to direct forward the traffic towards a specific path. But there are some parameters of policy-based routing that are basis on the source, that is basis on the destination, or maybe on the combination of source and destination both, or as well as you can say on the basis of the services also you can define the policy-based routing. Apart from that, the second advantage PBR gives you is the optimization of network performance. It's going to optimize the network performance. So that's one thing, as well as like, it can be forced to do the load balancing as well. And we can say that apart from all these various advantages, that the different users can go from different directions. So we'll say different users can go via different directions. So this is like one more major advantage we have. And, basically we have some kind of load sharing as well in case of policy-based routing. But that is like not the part we are going to discuss about the load balancing in here. So I'm just mentioning an advantage that we have load sharing. So when I say load sharing is basically comes up with some CCIE level things. So in case of load sharing, when I say that load sharing, it's something that it can be used to configure multiple paths between same source and destination network by just distributing the traffic between them. And just by distributing the network load, it's going to give you better, fault tolerance. So I'll add one more advantage, that by doing the load sharing, we are also going to get some kind of fault tolerance, and also we can say that it's going to optimize the performance of network in short. So that's one thing. And we can say one more advantage for policy-based routing, that is compliance. Now, in case of compliance, why I'm saying compliance? Because it can be used to ensure that the compliance with the internal policies or whatever the external regulations are there. For example, you can route a traffic through VPN or a firewall to ensure the compliance with security policies. So many things are like that. So the major advantage we are getting with the policy-based routing is that it's going to provide you a greater control over the network traffic, as well as you can directly send the traffic among specific paths basis on the predefined policies which you are going to define. And always take care of this statement that whenever you are defining the policy-based routing, so these conditions will be checked priorly before the routing table. So we'll see that same thing in the lab as well. Now, there are two more points which I would like to add here where about the policy-based routing, like if the packet is matched in the route map, because there should be some route map statements which we are going to, define while doing the policy-based routing. So the first statement is as such nothing, but if the packet matches, let's say, I'm gonna say packet matches as per the route map, or you can say in the route map, because these route map statement needs to be defined. So once it's going to match the packet in the route map, then it is permitted. And permitted in what sense? Permitted in sense to send the packet according to the policy, whatever the policy you are going to define. Suppose that I am going to define one policy over this, that over the router number 3, that there are two networks, 12.0.1 and 1.1. Or let's say there is one more loopback, which is 12.0.2.1 having /24. Now I just want to make sure that 12.0.1 and 12.1.1, they'll be using my primary link, which is this 1.0.0. So for this, I have defined 12.0.0.1 as well as 12.0.1.1. So I have this requirement for the primary link, whereas my secondary link is like 2.0, which is like going to use the 12.0.2.1 network. Whereas let's suppose there is one more network, which is 12.0.3.1/24. So in this scenario, or if there are any other networks, if we are not going to define any other policies apart from this, like primary or secondary link policies, which we have defined. So in that case, the rest of the remaining traffic will be used and will be forwarded by the basis of the default policies, which we are going to implement. So it's not like the PBR part, whenever we are like defining the PBR part is only going to take care about the policies which you are defining inside the network. So in my scenario, the primary link is going to hit the traffic of 12.0.1 and 1.1, whereas secondary link will be using the traffic of this network only. Apart from that, if any other network is there, which is advertised on the router number 3, that traffic will be forwarded via the normal routing routes. So that is one thing, and that's what the point I have mentioned in the next slide, that if the packet is going to match in the route maps, then it is permitted according to the policy. If the packet is not matched, then it is denied. So I'll say if the packet is not matched, then in simple we can say it's denied. So that's what one thing we have with the policy-based routing. Now let's try to understand the syntax for policy-based routing, how basically we are going to configure the policy-based routing. So first thing to configure the policy-based routing is to make sure that you are going to define the route maps. So I'll say the heading is syntax for PBR. Now in the syntax, the first thing we have to create is the route map. So let's say you have to configure a route map over the device. Now, basically, when it comes to defining the route map, you'll be simply saying to define the route map, let's suppose that we have a router whose name is R1. And over router 1, let's say you are on the global config mode. And let's say that how basically the route map statement can be implemented. So to define the route map statement, you are going to say route map. That's the first keyword to use the route map. Then after the route map, you have to define the name for the route map. that what exactly the name you are implementing for the route map. Then after you have to define the permit or deny entry, that is this traffic is permitted or is it like you can say denied or allowed. So that's one thing. And then after there is a sequence number which is also being used. So this sequence number is defined in the route map. Now, once the route map is configured over the device, the second requirement we have is in the syntax is to define the condition to match. So we'll be defining the condition to match. Now, what exactly this condition is, which we are going to take care of and how it's going to match inside the device. So once you're going to hit the command for the route map part, then your device will be there in the route map. So I'm simply going to say it will be like configure terminal. And apart from that, it's going to show you something like route map because we are inside the route maps. Now, once it is done, the second thing is you have to match the traffic. So whatever the ACL number or whatever the IP address is there, you have to take care of that. So you will say match IP, and to permit or allow or deny the traffic, we are definitely going to use some access control list inside this. So ACL will be used. So you will say match IP address or ACL number, or also you can say match the interface. After that, what type of interface it is, basically type in the sense that it is a gig interface or FA0 interface like fast Ethernet, and then after whatever the number of the interface is. So while defining the route maps and after defining the conditions, after matching the traffic with the ACLs, this is the part you are going to see over the devices. Then after that, you have to go over the specific interface where you have to define some policies for the PBR, where the actual implementation is going to happen. So I'm going to say implementation of PBR. And no worries about the syntax part. If it is not clear, guys, I'm definitely going to share a lab guide with you where each and everything is written more in detail. So just please ignore these part. Like I'm just assuming that we have a router just to show you the syntax part. Now implementation of PBR, like you're gonna be on any kind of interface, let's say, wherever you are going to put the policies. So over the interface, you are simply going to say IP and you have to say policy. And then after you have to say route map because the policy you are going to execute it with the route map. And once it is done, then you have to give the name for the policy as well. So that is how the complete syntax looks like for the policy-based routing. And there are some advantages which we have already discussed. So we'll take a lab scenario to see how basically this policy-based routing is going to work on the basis of source. And then I'll also give you a glimpse over how basically you can go and configure it over the basis of your, you could say, source and destination, as well as there are some services which can be implemented as well. So we can define this on these basis of parameters like source, destination, source based, and all these things. So let's don't waste much time on theoretical discussion and let's directly move towards the lab section. So just a moment, let me share my lab screen. So as you can see that I am having few devices here, router 1, 2, 3, and 4. Sorry, 3 devices are there, no 4 devices there. So over the topology, as you can see, the points which I have mentioned with the yellow color, that traffic sourced from 14.0.0.1 and 14.1.1 should be forwarded via router 1 gig01 link, which is the 1 dot network. That's my primary requirement, that most of the traffic will be going via the 1 dot link. And secondly, the traffic which is sourced from the network, which is you can say 14.0.2.1, that should go via my second link. And over these devices, before doing the policy based routing, there are a few prerequisites that the routing should be done and enabled over the devices. So I have already configured some IP basic configurations. Second thing is to make sure the reachability should be there. So let's go on the router 1 to verify. So on the router 1, as you can see, I'm going to run the command enable. Okay, let's verify. Meanwhile, on the router number 2. So this is R2 screen, and on the router 2 will verify the interfaces. I'm simply going to run the command show IP interface brief. And inside the IP interface brief command, you can see that we have gig00, which is associated with 1.1.2, gig01, which is associated with 2.2.2, and we have loopback 1, which is associated with 12.1, 12.1.1, 12.2.1, like this. So apart from that, if you will verify the IP addresses on the router number 3, enable show IP interface brief. So you can see all the executions are already done over the router number 3 as well, that accordingly to the loopbacks and as well as the physical interfaces we are going to have. So now if I'll run the command show IP protocols on the router number 3 to show you that is there any routing configurations done or not. So you can verify that as of now, there is no routing protocol configured over my device. So similarly on the router 1 and router 2 as well, there are no other configurations. You can run the command show IP interface brief to verify the IP addressing part. 3 interfaces are there. And guys, just one more thing I'd like to show you. Over the router number 3, if you will see, there is a physical interface which is saying 40.1.1.1. So this 40 dot network, I'm just assuming that this is basically my local area network, because I have not used real-time switches and like the PCs which are connected to my local area network. So directly I have executed one IP address to the gig01 interface, which is saying 40.1.1.1 as well. And apart from that, like rest of the IP configurations are already mentioned in front of you. So initially, from the starting part, as of now, there is no reachability and there is no protocol configured over the devices. So I need to make sure the reachability should be the first part over the devices. So to define the reachability, I'll simply say configure terminal. And over the router number 1, I'm going to configure some EIGRP. Let's say router EIGRP process 100 we are going to use. I'm going to say no auto summary. Then we'll define the networks. So we are having 3 networks, 1.0.0. We are having one more network, 2.0.0. There is one more network, which is 10.0.0.0. So these 3 networks are there over the router 1, which I have advertised. Now, similarly, I'll be doing the same configurations for my router number 2 as well. So let's go towards the router 2, and I'm going to say configure terminal, the router EIGRP 100, no auto summary. And then after I'm going to say the networks. So I'm going to initially advertise the 12 dot network. Then after saying the 12 dot network, I'm going to say the network 1.0.0.0. So you will see that the dual algorithm log will come up, because the EIGRP is going to use the dual algorithm. And with this as well, we'll see the log. So now the EIGRP neighborship is being established between the VIOS 1 as well as between the VIOS, you can say between the 1 dot network and 2 dot network. Now, we have to make sure that the router 3 should also be able to reach the router number 2. And only that case, we are going to put the route maps and the policy-based routing over there. So reachability is must. Let's move towards the router number 3. And on router 3, I'm also going to configure once again EIGRP process. So I'm simply going to say router EIGRP 100. And I'm going to say no auto summary. And after this no auto summary command, we basically have some kind of things like we can say the networks to advertise, which is network 14.0.0.0. And again, then I have one more network, which is 10.0.0.0. So these are the two networks, 14 and 10 dot network, which are there over my router number 3. Now, first of all, I am just going to verify the communication. If I'll say do ping 12.0.0.1, I'm reachable. If I'll do ping 1.1.1.2, I'm reachable. If I'll ping with 2.2.2, so I'm reachable. So the reachability part is done. Secondly, now the next thing we have to do is we have to make sure that some policies we will be using in such kind of scenarios, or even though you can also manipulate the bandwidths, but as of now I'm like not really going to manipulate the bandwidth, because that is something a different part. So we'll see that thing in the part if it is going to come up, or we'll leave that by just not manipulating the band. As of now, you can see that policy based routing, there are 2 conditions which I have given here, and the conditions are the traffic which is sourced from 14.0.0.1 and 14.0.1.1 should go via the router number 1 gig01 interface, as well as the second requirement is that the traffic sourced from 14.0.2.1 will go via the router number 1 gig02 interface. So that is something the primary and secondary which I have explained you. So the 14.01 and 1.1 traffic will be going via the 1 dot network, and the 14.2.1 will go via the 2 dot network, and remaining we can say that it will go via the default routing path, which is like basically according to the EIGRP, what EIGRP will be advertising. So all the interfaces and all the executions are done here over the devices, but I guess we have not advertised the router number 340 dot network in EIGRP. So you can verify. See, only 2 networks are advertised. Let me just verify again. Router EIGRP 100, and I can say the network we have 40 dot network as well. Exit. So that's one thing. Now to verify, we will be using some debug IP policy command, which we will be doing later on, and we have to put some ACL statements. So basically, I'm just simply going to enable one command, which will later on verify. Now, as per the requirements and as per the conditions, according to the policy-based routing, which we have here, the second thing, we have to make sure that there should be some ACL statements which should match the traffic for 2 networks. The first traffic will be, or the first ACL statement to match the traffic will be with 14.0.1 and 14.1.1 because I have to match the traffic. The second ACL statement I am going to write for the 14.2.0 network. And after this, I am going to create the route maps, and accordingly, I'll be implementing the ACL statements also. So while defining the next hop, like in case of ACL, or you can say while you are going to define some kind of policies, you can also use the exit interface. That part I'll be letting you know when we are going to define now. So let's initially start with the policy-based routing, and up to the routing part, it's I hope pretty much clear to every one of you. Now I'll be going on the router number 1 to implement the policy-based routing part. Now this is my R1, and on the router 1, first of all, I'm going to write 2 ACL statements just to match the traffic. First is I'm going to say access list. Let's say the access list I'm using 14, and the permit entry I have to because the scenario is I have to permit the network. So I'll say 14.0.0, and the wildcard mask I'm executing and permitting the entire 14.0 network. This is my first statement. Second statement I'll execute is for 14.1.0 network. So these are 2 statements which are there for the first condition you can see here, which is mentioned in the yellow section here. Traffic source from 14.0.1 and 1.1 will go via R1 gig01. So given the statements here, secondly, I have the another statement, which is basically for the second condition. So I'll say access list 15, and I'm also going to permit the traffic, which is 14.0.2.0, 0.0.255. So second statement also I have permitted. So we are creating the ACLs which are matching the first and second conditions just to match the traffic. Now the second thing is we have to create the route maps. Now to execute the route maps, what we are basically going to do, we will be doing that, we'll say route map. And then after saying the route map, if you are going to put question mark here, see, it's asking you for the route map tag. That is nothing but just the name for the route map, that whatever the route map you are going to define. So I'll say that the route map name is PBR, or you can execute any name. Then after that, it's going to ask you that either you have to permit or deny the traffic. So as of now, I'm just allowing the traffic to permit. And after saying permit, if I'll put question mark, so it's asking me for the sequence number. So sequence number needs to be mandatory there. So I'm going to use any sequence number between 0 to 65535. I'm going to simply say 10 is the sequence number. Now you can see I'm inside the route map. The second condition is that now I have to match the IP address with the following statement which I have created in the ACLs. So you can see I have created ACL 14 for the 14 dot network, and 15 ACL I have created for the 2 dot network. So to match the traffic, I'll say match IP address And then if you'll put question mark, so see, it's asking you for the name or number of the ACL. Like if you are going to use the name based ACL, it's going to ask you for the name. If you are going to use the numbered based ACL, it's going to write the number as well. So you need to mention the number. So currently I'm going to match the traffic for 14 dot network or the ACL statement which we have created, like the 14 ACL number 14. Now once this is done, I have to set the next hop IP. So I'll say next hop set IP, and if you'll put question mark, there are various other options, like you can set the default information, you can set the global routing table, but right now I'll be using the next hop address. So set IP, and I'm going to say set IP next hop. Now once the next hop configurations are basically done, so after the next hop, either you can write the next hop to reach over this. So like the next hop is 1.1.1.2 accordingly to the statement. So this is one thing. So in case of the next hop, either you can use the next hop or you can also execute the exit interface. So that is your personal call. What do you prefer to use? But in some scenarios when dynamic IP is being implemented over the devices, so it's always better to use the exit interface rather than using the next hop IP. Now, once this statement is done, I have to exit from here. So I'll say exit. Now I'm on the global configuration mode. Now I have to create the second route map statement, which is there for the second condition. So I'm going to create the route map again with the same name, but I have to change the sequence number if the condition is changed. So I'll say route map. So that's one thing. And the PBR is the name for the route map. And I'll permit the network. And now I'm the sequence number currently I'm using is 20. So every condition will be determined by the sequence number, which you will be using in the policy based routing. So that is one thing. Then after creating this part, we are simply going to say match IP address. And now I'm not going to, let's say the statement which we have created in the ACL for the second condition. So we have used the ACL 15. So I'll match this traffic. Then after this part, I will use the set, not the next hop I'm going to use. I'll say interface in the command section. Like if you do remember when we discussed the same thing in the theoretical discussion. So saying that set interface, and if I'll put question mark, so a lot of options are coming up. But as of now, I will simply say that the interface and the IP address of the interface, I'll be using this 2.2.1 interface, which is gig 0/1. So I'm going to say gig 0/2, where the 2.2.1 is there. So for the second condition, the traffic is going to reach on the router number 2 via this interface only. If I'm going according to the second condition, so I'll say set interface, but see, it's giving me a warning that using the point-to-point interfaces for route map set interface clause. So it's like not really recommended, but in case if you are executing such kind of scenarios over the real-time devices or real-time enterprise networks, and over the network, suppose that instead of physical IP addresses here, like the static IP addresses, your organization is using some kind of dynamic IP addresses. So in that case, you have to take care of the execution, and it's better to always go with the exit interfaces rather than just providing the, you can say, next hop IP. Because if on the next hop, suppose that on the router number 2, that is going to be your next hop, and over the next hop, and if you are using dynamic IP, so automatically it's going to change. And if you have set the next hop IP as 1.1.2, and suppose that after 24 hours the IP will be flushed out and a new IP will be coming up, so in that case the statement will not be allowed, because the traffic will not be permitted, because the next hop you have set as 1.1.2, but with the dynamic IP the next hop changed. So it's always better in such scenarios to go with the exit interface. So just for your clearance and verification, I have used both of the scenarios. On the gig 01, on the above network 1.0, I have set the next hop IP, and on the second statement, I have set the exit interface. Now, after doing this part, I have to create one more route map with the different sequence number, because there are 3 conditions. The third condition is not written because the third condition is as such nothing, but remaining traffic will be going via the default EIGRP route behavior. It may be go via 1 or 2 depending upon the EIGRP route part. So I'm going to say the route map, and the route map name is PBR. And then after I'm going to say permit, and the sequence number I'm going to use is 30. Now, as of now, you can see that I have created 3 different route map statements. Route map first is going to have the sequence number 10, where that is basically for my first condition. Route map sequence number 20 is for my second condition, and route map 30 is basically for permitting the remaining traffic. So now I am not going to write anything here because I just want to permit this remaining traffic. So I have to leave this as it is, like the way we are going to define. So after this, now we have to say, like, if you will be verifying, just a moment, do show history. Okay, all right, no problem. Now the final step is to, remember that whenever you are executing the policies, there are 2 methods to execute the policy, which means, like, if I'll share my slide screen once again to show you. So on my slide screen, when we were discussing the, just a moment, let me reshare my slides. So when we were discussing the policy-based implementation, like how the syntax will go. So you can see the first thing we did on the devices was defining the route maps. Second thing, to condition to match or deny the traffic. Third thing was the implementation of PBR. Now, whenever we are doing the implementations of PBR, we need to take care of few things, that there are 2 possible ways to exactly go and configure the policy-based routing over the devices. First condition is that we always we can either apply the implementation over the global configuration mode, or you can also go over the interfaces. So as per the official Cisco documentation, Cisco never recommends to go with the global configuration mode, and even though it's not really recommended in the real-time enterprise networks, but we always implement the policies on the basis of the interfaces. So we'll be using the interface from where the traffic is being originating. So you can see that in my scenario, on the router number 3, the traffic will be originated from the router 3. And then after originating the traffic from router number 3, it's definitely going to reach on the interface gig 00 of my router number 1. So on the gig 00 interface, I have to execute the implementations of the policy-based routing, which the last syntax command says. So I'm simply going to select the interface, which is gig 0/0 on the router 1. And I'll say 0/0, and then I'm going to say IP policy, and I'm going to say route map. And then after saying the route map, if you'll put question mark, it's just asking you for the name of the route map. So that was the reason I have told you that you don't need to change the route map name, but the sequence number should be different for each and every condition. So that is one more prior thing. So once you are going to execute this command, now the complete policy-based routing configurations are done inside the devices. Apart from this, now any traffic which will be received on the router 1 via the router number 3, it will be policy-based. So let's try to verify. So I'll go on the router 1, and I'll just simply run the command end, and I'll execute one command, debug IP policy. Now, as of now, I have enabled the debug command. I'm trying to generate some traffic. So let's try to generate some traffic from the router number 3. And then accordingly, we are going to verify the debug output of the router 1 as well. So let's open the CLI for VIOS 3. And on the VIOS 3, I'm going to execute some traffic. Let's say I'm going to say ping 12.0.0.1 from the source. And the source I'm going to use is 14.0.0.1. Okay. And let's copy it. Now you can see the communication is successful. Let's go to router 1. You can see I'm getting some kind of logs here. You can see that FIB policy match because I have created the policy based routing, and you can see that from where the traffic is, like from on this particular see The IP is this, that the source was 14.0.0.1, which was sent on the gig00 interface, and the destination was 12.0.0.1. And the traffic is going via on the destination 12.0.1 after matching the policy based routing. See the first log, policy based routing matched. And here in the output, you can see it's using the link gig 1.1.1.2 as per the policy we have executed. Similarly, you can see the complete output here. So that is one thing. The first verification that the traffic 14.0.0.1 is reaching via, or this 14.0.1 is gonna go via the link number 1, which is having the IP address of gig 1.1.1.2, as you can see, because we have set the next hop as 1.1.2. Second thing I'll do is I'll try to ping and I'll change the source address to 14.2.1. It's also successful. I'll go here and on the router 1, similar configurations are there, as you can see. FIB policy matched here, and we'll verify the IP address. You can see that I have set 14.0.2.1, and 2.1 is using the gig 0/2 interface, which is the router number 2's interface 2.2.1, because as per the condition, the 14. Is coming to the destination part, which I'll be just giving you a glimpse over the slides, that how basically we are going to configure the policy based routing on the basis of destination. So this is basically on the basis of source we have implemented, but on the basis of destination, on the basis of services we can implement. So that is what about the lab section of the policy based routing with the debug verifications, that you can see both of the outputs are there in front of you. The 14.0.0.1 traffic is going via gig 0/1, or you can say the next hop is 1.1.2 mentioned in the output also. You can see the 14.0.0.1 is the policy, and that traffic is hitting via 1.1.2, whereas the second policy is 14.0.2.1. It is using the exit interface, because I have not defined the next hop in the second route map statement. I have defined the exit interface. To verify the route map, there is a command. You can simply run the command do show route map. So you can see these are the specific configurations you have executed over the devices, and you can see the IP next hop you have set, and inside the second you can see you have set the next exit interface. So that is how the route map statements and the complete policy based routing is going to work. Show the routing table of R1 short, please check. Show IP route. So that's the routing entry for the router number 1 is. So I hope, Jayant, your query is also clear to verify the routing table as it is in front of you, to verify everything is there. And that's how we are going to implement the policy based routing. Let's move towards the next thing, which is there according to the destination basis. And in case if you want to execute the policy based routing on the basis of destination, so there is a different thing which comes up with the destination. Implementing the syntax part will be same, either it is service, either it is your, you can say, destination, or on the basis of source, but few different things will come up, which we'll see now. So I'm just going to share my lab screen first of all, the slide screen first of all with you all, so that we can have a better idea as well on the basis of destination, that how it will be implemented inside the devices. So here is my slides, you can see. And I have pasted the snip of the lab, which we did here as well. Now to check on the basis of destination based PBR. So basically the destination based is something you have to, create some different statements for that, because every time conditions are different. Whenever you are defining the policy based routing, conditions will not remain same. So conditions will always change. So I'm not going to show you the lab for the destination basis, but I'm gonna give you an idea that how you can implement the PBR on the basis of destination as well, which you can try it yourself. Also, I'm gonna share one lab guide, which you can take help from the lab guide. So let's try to see. In case of the PBR, which is gonna be on the basis of destination. So basically, the first thing you will be executing the access list just to permit the traffic, because if you are not going to permit the traffic, then it's not really going to work. And permitting the traffic is the first and foremost part we have to always take care in case of the devices. And how it will be implemented, just a moment. So guys, see, I'm going to show you the same syntax, and I'm going to help you out with the configs as well. So first thing is that whenever you will be executing the statements for the destination basis, so with the lab guide, you can see, but just a reference I'm giving you that how it will be done. Suppose that the first config you will be executing is, the config you will be executing is managing the access list to permit the traffic, let's say IP access list. You can go with extended or standard ACLs on the basis of names as names. And so, you have to say extended in case if you're going with the name based ACL, and you have to give the name as, let's say you are going to define path 1. So that's the first statement. Then you can say that permit IP any, because you are permitting the traffic, and then saying this command, whatever the traffic is there, let's say 12.0.0.0 using the wildcard mask 0.0.255. And similarly, the same config you will be executing once again, but you just need to change the network. And here you are going to say, instead of 12.0.0, you'll be saying 1.1. So that is how you are going to define. And this is how the extended ACL will be implemented. And remaining things will be same like the way we did in the last section, but on the basis of destination, you need to change the scenario. So in case of destination basis, I'm just giving you one, kind of assessment or a practice lab where you can use the following syntax, which we did in our lab section. So let's suppose that this is the topology, and to make sure that you are going to run the destination based policy. So I'm giving you some requirements or some conditions where you can say that the traffic destin for the network 12.0.0.1, or you can say the complete network 12.0/24, as well as apart from this, you can say 12.0.0.1.1. The traffic which is destined for 12.0.0 and 1.0, you can say from any source of router 3 will be forwarded through, or you can say will be forwarded via the interface gig0/1. Interface gig0/1 of R1. So that's my first condition, which I'm going to define. And second condition also, you can similarly define like this. I'm just going to copy paste. So second condition is that any traffic which is destined for, let's say 12 dot, you can create one more loopback 3.0, or you can create like 2.0 is already there. And here also 1.0. So any traffic which is destined for 12.0.3.0 and 2.0. So 3.0 loopback is not really there, but for practice, you can create the same, will be forwarded via the interface. You can say, let's say, suppose the second interface, which is gig0/2 of the router number 1. So like this, you can take, and remaining traffic, you have to make sure that uses the default path. So remaining will use the default path. Default path, not in the sense like you'll be going with the default routings, but we have to make sure that the default path which the routing protocol is configured. So you can go with any IGP routing protocol. You can go with BGP as well. That's your personal call. So remaining will be use the default routes. So as an assessment, you can practice this lab, and I'll be sharing one lab guide in our Telegram group. And you need to make sure that this basically statements will be matched according to the syntax, which we have discussed in the previous slide here. So all these statements are mentioned, and that's a practice lab you can take. And from the notes and all these notes and the slides I'm going to share in the Telegram group. So if you have not joined our Telegram group, so I'm sharing the links to join the Telegram group. So you can join the Telegram group where I'm going to post the lab guides as well as the, you can say this particular notes as well for the webinar. So just a minute, give me a moment. I'm sharing the link. So I'm sharing the link in the chat box with everyone. So you have, in case if you have not joined our Telegram, so we do post our quizzes and a lot of things are there. You can join our Telegram group. All the resources related to the webinar, like your lab guides and the notes as well, will be shared in this the group. And any queries if you guys do have from the policy-based routing part we discussed, so you can raise your queries over the chat box. Done with the lab section and we are done with the webinar, but now it's time for the queries. So I'm ready to answer your queries. So do share your queries if you do have any. All right, so if there are no queries, we can wrap the webinar. So that is all about this complete policy-based routing webinar, and I hope every one of you find the webinar pretty much useful. In case about the webinar or in lab sections, if you are going to have any sort of queries, you can feel free to reach on Telegram group, which I have shared the link with you all. So you can check out the link and there will be always ready to help you out the queries. So you can practice the lab as well. Assignment is already there. Notes will be shared. And yes, Jayant, like policy-based routing is not a part of CCNA trainings, but it is a part of CCNP ENCOR training. And with the revised syllabus of new CCNP, it's there with the CCNP ENCOR. But previously, like before a month, it used to be in the CCNP and ENARSI trainings, like which is advanced routing and switching. So not in the CCNA particularly. Okay, then. All right. So I hope all the queries are sorted. Any queries, if you guys do have, you can reach to me on Telegram channel, which I have shared the link. So that's all for the webinar. Thank you for joining, guys.
Thank you.